We are going to use the second do file, that tsnurt do file.
Okay.
That is the do file we are going to use. So you can launch your Stata and open that do file. So, like I said, the first thing, whenever you want to carry out an analysis in Stata, the first thing is to make sure you change your working directory to the right folder. Right, the folder that contains all the files we'll be working with, be it your data set or your do file you want to use for the analysis. Okay, so I've already done that. So to do, you can just go to File, go to Change Working Directory, and locate that particular folder where you have all the files you will be working with. Okay, so I've done that already. When I did that, so it's returned this code. So I just copy this. Okay, so I copy and pasted it in my do file, so that in case of next time, I won't need to be doing that again. So I'll just be running directly from the do file. So I've done that. So once I've set my working directory, so to import my data, I won't need a very long code. So I'll just type import exe because it's an exe file. Then, so I put in inverted commas. So I have data. This is the name of the data set, data1.xlsx. Then comma first row. That is, the first row serves as the variable names. So the next thing, now I want to import my data set. So data set imported. Then you must declare your data set as time series before you can run this unit root test. So I'm doing that now. So I just run the code in line 49 to do that. Let me even check the Stata environment if there's anything there. Okay. Yes, I think we are good to go. Okay. Now, because for this analysis, I want to use exchange rate. And exchange rate I'll be using is at level. So are you with me?
Yes.
So the exchange I'll be using is not in log form. I won't be using log of exchange rate. Okay, I won't be using log of exchange rate, but I can just generate it in case I want. I have reason to use it. So let me just generate it in case. But for now, I won't be using it. Okay. So now the first thing is to know the command to be used for this kind of test, non-linear unit root test. The command is TARUR. Okay, TARUR. That is the command we'll be using to run it. So we can read on the command. So let's read about the command. So if I type F, then the name of the command, TARUR. So it will bring details about the command here. So you can see we have about 15 non-linear unit root tests there. 15 non-linear, these are the unit root. We have about 15 unit root tests here. That is non-linear unit root tests. Okay, so these are the tests we will be conducting in this class. At least some of them, and I'm going to guide you how to conduct those that we won't be able to conduct due to the limited time we have. Now, so if you read the first thing before we can carry out a non-linear unit test. So the first thing we have to test for linearity in any series you want to test. For example, let's assume this standard unit test like ADF, PP test, and KPSS and other popular tests we know, they assume linearity because they always assume that a series follows AR process. It follows linear AR process. Okay, that is the parameters and the series itself. That's the lag of the dependent variable. It is linear. You won't find, in AR specification, it's just like you say YT equals, let's say you have A plus B YT minus 1. That is a linear equation. That is a linear equation. But what of the situation whereby we have YT equals C plus B Y squared t minus 1. You can see that one is non-linear invariable. Okay, that is non-linear variable. So we will be capturing a process like that in this non-linear unit 2 test. So it assumes non-linearity, that if a series is not stationary, when we assume linearity, okay, is it going to be stationary? Like, what of if we assume non-linearity? Is it stationary? So that is the idea behind this. Instead of saying y t minus 1, why can't we just square that y t minus 1, or we cube it and say y t minus 1 raised to power 3? Why can't we do that? Or we also assume asymmetric, that positive shocks have different magnitude of impact from that of negative shock. So why can't we assume that? So that is all about, that is what non-linearity is all about. Hope you understand what I'm trying to say.
Yes, yes.
Okay. Now, these are some of these tests. So before we carry out this test, we can, as a preliminary test, we can just test for linearity. So if you test for linearity, whether that series follows a linear model, if the non-hypothesis of this linearity test is rejected, it means we can now proceed to non-linear unit 2 test. Okay, but if the result of our linearity test says that that process is linear, so there is no point in carrying out non-linear unit 2 test. So we only carry out non-linear unit 2 test if this pretest indicate that the process is non-linear. Okay, and the test we'll be using is sterile vector test of linearity. This is the test I'm showing here. We'll be using it. You can see it is here. So to run the test, let me just copy this command. I don't think I included it in the do file, but I'll just do that now. Okay. So now let me do that now. So I want to add to that linearity test, linearity test. Okay. So here is I'm typing the command then the name followed by the name of the test I want to carry out. This is the general package, then the name of the particular test I want to carry out. Okay. Then I'm going to use exchange rate. Let's run this test, linearity test, whether exchange rate is linear, and see. So the test reject the non-hypothesis of linearity. So it shows that this exchange rate, this series follows non-linear process. Okay, non-linear process. It follows non-linear process. So we are good to go to know that. So let's also confirm. What if we assume linearity? Let's assume we use the command we used last time, the command for running linear process, that linear unit 2 test. That is, you have start, then you have start, exchange rate, then let's run the test first. Let me run ADL. Okay. You know, this one assumes linearity. So let's see if the series is stationary at level. You can see exchange is not stationary at level, but it's not stationary at level at all. Even at first difference is not stationary. Can you see? Using this ADF. Okay. The implication is that this series may be non-linear, may exhibit non-linear behavior as indicated by this linearity test we just ran. Okay, you can see it's not stationary. Even at first difference, it's not stationary here. What of if you use non-linear test? Is it stationary? Okay, so that is the point there. And the test for linearity that shows that this series exchange rate exhibit non-linear behavior. Okay, so there are two ways of running these tests, all these various tests. I can run 11 tests together at the same time. Okay. For example, if I type this command, then I put the option run all. Okay. If I put exchange rate here, if I put exchange rate here, okay, then the case is it is advised by the authors of this test that we should always use the mean, okay, the mean, okay, or sometimes the trend, but the recommended one is the mean, or the case will be the mean, okay. Then the maximum lag 12, then we use lag method, AIC, which is default. If I don't add all this, I'm still going to get the same result because this is the default, okay. So if I run this test, let me run this test. You can see I've changed this to exchange rate. If I run this test, let's see the summary of the result. You can see here's the result, okay. Here's the result. So I have this for KSS. So we cannot reject the non-hypothesis because this test value is less than this. Can you see? It's less than this. Okay. For this cruise, is also we cannot reject. But for Solis 2009, we can reject the non-hypothesis. So according to Solis 2009 test, so this model, I mean this series is globally stationary. It's globally stationary. I think it's only the test that assume that it is stationary, which is Solis 2009. Actually, this one support the stationarity. Okay, if we take into consideration non-linearity. Okay, so this is the summary. But there's other tests that are not included here. Okay, so we can go with this Solis. We can go and run this Solis separately to have details about the test. Okay, now that is what we are going to do here. So I want to do that here. Look at it. I say for a particular test, replace run all with, for example, we have Kilik test, or we can also use Solis 2009. So I'm changing this variable to EXR. Okay, so let me run this to find detail because the initial test, because I run all, it gives me the summary of the test. So if I run a particular test, it's going to give me details about that test. So let me run that now. So this is the result of the test. So I got Solis 2009 asymmetric ESTA unit root test. Okay, like I said, this ESTA means exponential smooth transition autoregressive model. Exponential smooth transition autoregressive model or autoregression, like unit root test. And the non-hypothesis is that the series contains unit root. The alternative says the series is globally stationary, symmetric or asymmetric. So this test will give me two. So this test will give me two variant of test. For example, we have test statistics here. Okay, we say Solis 2009 asymmetric ESTA unit root test. So I'm going to have two different tests under this. I have test statistics. That is the general test. Okay, this one will tell me whether it is stationary or not. If I compare this 5.149 with this, the critical value at 5%, 4.954, you can see it is greater. So it means that we reject the non-hypothesis of unit root. So here we assume that it is globally stationary, symmetric, or asymmetric. So you can see here we still have two things, symmetric or asymmetric. We now have a symmetry test to know whether it is globally stationary symmetric or it is globally asymmetric ESTA. Look at the symmetric test here. Are you with me?
Huh?
Okay, look at symmetric test here. You can see this symmetric test shows that though we are not going to accept the significance of it because it's less than, because this p-value is greater than 0.05. So we are working with 0.05. So we are going to assume that this series exchange rate is globally stationary symmetric ESTA, not asymmetric ESTA. Why is it not asymmetric, Esther? Because this test is not significant. Okay, so the conclusion will now be exchange rate is globally stationary is globally stationary symmetric S star. Can you see? That is, if we use S star model, it is globally symmetric, but there is no asymmetric evidence of asymmetric there. That is what that one is trying to say. Okay, we can also run other tests by simply, so we also have, so you can see, if you study the structure of this, you will see. So I can also run KSS. So let's run this solely 2004. Let's see the behavior, whether we are going to have different results. Let's see. Okay, so I'm not supposed to put, it's warning me that I'm not supposed to put lag method there. That does not accept lag method. So let me just remove that. So let me just remove everything we have there. So this one and 4. So I have the test here. Okay, this one is a direct test. So it does not show it. The alternative is straightforward. It's asymmetric threshold Ahab stationary around smooth transition. Can you see? And we cannot reject the non-hypothesis. This one is not stationary. It's not stationary. It's not asymmetric Ahab stationary around smooth transition. Okay. So that is why, when you compare with that Solis 1 and 9, Solis 1 and 9 says that it is stationary, globally stationary, right? But this one says it's not asymmetric. Yeah, that means that the result of second test is okay when you compare with this, because the second test also rejects the asymmetric behavior of the series. Okay, and this one is also tells us there is no asymmetric. Okay, but that one is telling us that they are symmetric. Okay, the only problem this one has is that the alternative hypothesis is not symmetric. There is no alternative hypothesis that is symmetric there. That is why this one is rejecting. Okay, so we can also have KSS test. This is another KSS. This is another one. Okay, although this KSS is not asymmetric test. Anyway, just non-linear test without asymmetric. So I have this. So it's also failed to reject. This one just say globally stationary S star. Okay, so globally stationary. So it's just symmetric. So it's not about asymmetric. So that's why in the do file I've grouped this test into two. You can see I have asymmetric here. This represents asymmetric test, and this represents symmetric test here. And you see, so and this particular test, Uchin test, we have. I mean, look at this one, like Vulgar test has 5 models. Model A, B, C, D, E. Okay, and you have options there too. So play around that. Okay, so you can always run these tests and compare the result. Like this Fanga, where is it? This last one, I can also run this one. Let me run this last one, this Vulgar test. Okay, so also free to reject. Okay, so the bottom line is that if you want to judge whether a series is non-linearly stationary, okay, so we have to compare this. Is this one you are going to compare? Symmetry, you compare symmetric with symmetric and asymmetric with asymmetric. Okay, so you cannot compare symmetric with asymmetric. Okay, if your series, if you run this test, any of these tests, and it indicates asymmetric, so you can run multiple of these tests and compare the results. Okay, but if there is no sign of asymmetric, so there is no point in running this test, because this test is about asymmetric. So just stick to this test and judge by the majority.